Okay, so we're going to continue on the context and retrieval. So going back to user, so you're going to give a prompt, right? The food was cold and arriving late, and the response will be, I'm sorry to hear that the food was cold, we can offer a refund. Um, so for simple stuffs, you can actually do a very simple basic prompting. Now, why this is important is, let's say, if it is just one shot or a free, let me show you a few shot, right? Examples. One second. If you see this, it's going to see, it's going to understand all the context that it has, and then it's going to answer. But if you do not give much of the context, then it will also not be able to understand much, right? If you see, it says, okay, this is about the flight have Wi-Fi, the food is cold, etc., etc. And then it says the service inquiry, it's a weak match, right? It won't understand. Let me actually see if I have any other options to show you what I mean. I know this is going to be a little tricky, but yeah. Okay, never mind. I'll cover it in the next phase. But yeah, let's understand about RAG, right? How it works. Um, Retrieval Augmented Generation. So why this was required is that people were using AI and it was all in the web, and then these big giants tried releasing the open source models, and which you can use to actually use those models locally, and you can build a system around it and put your own data inside it so that it can only learn about your data. But that model has everything already, right? It understands the vectors. I mean, you need to create vector search, of course, but yeah, you have a model which predicts, you have a model which learns, all those things. So how it works is, you give a query, it checks the question. The question is about return policy. You have shipping, privacy, and return policy documents given, which is nothing but a PDF file, and it only goes to that particular file and gives you the answer. So that's how it works. It does the query embeddings. It tries to check the attention. Then it says, okay, this is a vector. This is where the coordination is. The coordinates are, and then it pulls that information and then it gives you the information, right? Let's say. Also, yeah, that's how it works. If you see, it'll what is your written policy, it'll text the written policy, it'll give the answer, items can be written within so and so. This is nothing but this was already there in that. It just pulls the information from there and smartly updates. Let's understand vector database, right? We have been talking about vector so much. um, I love AI. See this. Okay, vectors again. Please understand the maps. And then if I say I love AI, it will start seeing what are the similar uh, phrases. Now I'm going from words to phrases, right? If you see artificial intelligence, it says it has so many things related to artificial intelligence and it tries to give similarities, right? So it will ask you, what do you want to learn about artificial intelligence? If I say programming languages, you see this, it will say these are the languages. Okay, this is not right example, I need to fix that, but you get the context, right? If I talk about quantum physics, let's see. Yeah, quantum physics, it has some data, so it will directly go and check the similarities and then give you the result of each, right? Let's see what is hybrid search, right? Machine learning. Now see, I said I want to learn about machine learning, but look at this. What it is trying to do is, it's trying to understand the vector relations and then the keyword around it. And then it says, okay, these topics are near this vector 100%. The keyword is matching, but if you see this neural network, the keyword is not matching. It's just 67%. So it'll give itself a score. Okay, it's 90% similar. I will see if I can give that. If I want a very good vector result, then it'll stream it down. Good models will actually filter it down and only give you the context which is actually right for that particular query. I hope I'm making sense. Okay, performance metrics. So we covered how AI understands. It is penalized and then it is rewarded. But how does it understand where should I stop? So for that we have some performance metrics, right? So we have query latency. For example, if we want to see if, okay, let's see if I increase the data, right? I have now 810 documents. Just consider that as number of texts or something, right? Because documents itself is something else in the AI world, but yeah, let's not go there for now. So yeah, this is how it is. It's going to check the accuracy, and then it's going to say, okay, the vector use approximately near algorithms. Then it has this. Okay, these concepts are very advanced, so we'll not go there. So we'll go to context engineering, right? Context window management. You see, this is a very beautiful one. Let's say there is a context window. The context size is around 6, 9,000, 8,000 tokens, right? But as more the tokens are, the accuracy reduces. The more documents you share, the more data you share and ask question, the accuracy would actually decrease if the context size is low. But now I think we already have a million token size, context size, so we don't have to worry. But there were times when this AI started, we had this limitations of context, but now it's 1 million. 1 million is very huge. Now if you see, this is what even now it happens at times when you're building a huge project. So as soon as the context goes up, the accuracy decreases. It starts forgetting what was exactly said in the past. So it won't remember the context which was spoken at the later stage. So that's how the context works. So you have to engineer techniques so that it can remember the context and then it can pull the data which was already spoken back. So there are a lot of concepts and interesting topics that it works in an AI. MCP, I'll cover this later. Let's go to agents. Let's understand the difference between agentic workflow, single agent and multi-agent workflows. Okay. Let's say we give a query. We say what is the stock price of Apple right now. Okay. Let's see how it works. So this single AI does not have any other knowledge. The knowledge is only till Jan. Right now means it knows it is 2026, but it says I am not able to access because my knowledge is there. Of course, some AI will say this, some AI will not give you any response, but this is how it is. But let's say it's an agentic AI, right? So what it does is it'll think, okay, user wants a stock price, I need to use financial tool. So I have a tool in my bag, I will use that, and then I will say, okay, get me this particular stock, and then it will say, okay, I have the price, I have the currency, I know how much it has changed. So I will say today 1.2% has changed. So you see how it is thinking, it is responding, it is reasoning in itself, how you think, how humans think. It's the same way, guys, right? So this was a difference between a normal AI and an agentic AI. So let's see how a loop works inside a single agent, right? You see this? It says, okay, latest Python. Okay, wait. User wants to compare Python with Rust performance. So what it does is, take a look. It goes, checks, thinks, comes, checks, and gives you the response. Okay, so it's the final answer, but it thinks. This is agent thinks. Non-agent doesn't think. It will only share the information that it has already been trained. That's it. Okay, now Very, very interesting. Okay, let me again, in this multimodal agent brain, let's see. Nowadays, this is what it's working. You would have seen those um, agentic apps, right? N8 and etc. So this is how it works. So what it does is, if it is a single brain, only one LLM, it does all the work. It is a manager, it is a coder, it is a reviewer, it does all the work. But now the situation is, the advanced apps that are being built, it's built on multimodal orchestration. What is this is, each model, LLM, Gemini, Cloud, Grok, OpenAI, whatever, is given a particular power, tools, responses, etc. So it coordinates among each other and then it gives you the response, right? Some LLM is better at something, some LLM is better at something, but we need everything to be best. So how it can be achieved is by orchestrating all these LLMs together and creating an app, right? So in this channel, we will be also covering the orchestration and multi-agent workflows. So please stay tuned, please subscribe, and you will definitely love the journey. Okay. Now let's move on to a concept called chain of thought. It's nothing but now you would have already understood how it works, right? So chain of thought is nothing but when you give something, it starts thinking, reasoning, and then gives you answer, rather than just generally a model which doesn't have a thinking capacity. It just directly gives you a response which could be wrong, right? So that's that. Multimodals. Okay, so if you see, multimodal is nothing but when you give a text and an image, right? And then ask query about that particular image. So what you're doing is you're giving two context and you're asking something. So it has to have an image vectors and text vectors, then understand the combination how these works. Of course, please remember, each LLM has its own vectors, its own techniques of tokenization. So every LLM will be different, they're not same. So that's why I was saying that each LLM has its own power, weakness, strength, like how any humans have. So that's how it, if tomorrow you are building an AI, you will have a different concepts altogether. Okay. So yeah, this is how multimodal is nothing but a particular LLM understands image, understands text, understands video, understands other data. Okay. Joint CLP. We'll not cover this as well. This is going to be too much. Okay, so this is like, oh, this is distillation techniques. So this concept is nothing but how a big model is transfused into a small model and how it learns. That's about it, right? So for example, let's see. This side, the teacher model is a big model, and this side, it's a small model. So that's how the knowledge is transferred from one LLM and a student LLM. Okay, and it's nothing but a small LLM. Knowledge transfer. So this is how the transfer works. And if you see, over the time, as soon as the training is finished, small LLM also gets better at a particular topic. So that's how small LLMs are built. Now, quantization. To understand quantizations, guys, I think you need to understand how bits works, right? Integers works. So just understand it's a compressed version of a model. That's it. I will not cover that because of the context of this video, but you have this tool with you to understand the model. So, but understand, the lower the bits means the quantization is lower. The model may have a problem in delivering the right result. The better the bits are, the model will have better output. So it's all about how it is compressed into this. And of course, if you compress some memory, it will definitely hallucinate and not produce the right result, right? That's that. And that's about it. And yeah, I think I have one more thing to cover. Prompt engineering. Yes, this is what I was looking for, guys. Okay, let's say we give a model a question, right? So what it does is, okay, 1 minute. I'll enable the thing. Once a prompt is given, it will start thinking, right? This is a very complex model, and that's why you see the LLMs which are now available. They say it's advanced reasoning, advanced math. So it's because it will not just calculate anything and give you. That's what it was happening in the pre release time during 2021 and so. But now, if you give some advanced math question, it will try to break it down how human understands the concepts, right? For example, let's see this. It says Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have? So as a human, what you will do, you will go back and see, okay, Roger starts with 5 balls. Okay, let me keep it aside. He buys 2 cans. Each can has 3 balls. So total new is 2 into 3, 6 balls. So total is 5, which is already there, and thus new balls that are there 6. So it is 11. So this is the power of how LLMs thinks, right? If you see this few shot, I'm just adding this, and so this is just to show you that the better the model is at reasoning, the better results it produces. But this is also a prompt engineering techniques that we will understand later. This is just an image. See, image is not seen by the model, guys. I hope you understand. There was one more. This we have covered. Oh yes, this was also very important. So I was telling you that this is a perceptron, right? Inside this, I showed you this is what is happening. But very important. So X is a input, X2 is a feature. So understand it's the dimensions that we are talking about, columns, features, whatever you want to call. Let's say there is a input going inside, and there's a weight which is getting calculated, and there is a cost function which is applied, right? And then this I don't know how I'll explain. This is a very advanced level, guys, but it's there for you to understand. So think of this as a math behind each of these dots that you have, and that's how it calculates the reasons, and it reasons, it sees the attention. It's all because of these mathematical intuitions, right? But yeah, you have all the maths intuitions given here. It shows you how it actually works, how it doesn't work. You see this, you increase the weight, what exactly is happening at the output. The more the strength is, the more the output is better. The more the bias is, the output is better. I mean, you can just play around with this, right? This is how self-attention works, right? It tries to see how the word is nearby and which word I should attend to, right? If you see this, it's giving itself attention score, and then based on that, it's trying to give you the result. That's that. I won't get into this. This is all advanced levels, but yeah, this, I hope you get an visualization on this, right? Imagine the 3D graph that I showed you. This is how the similarity works, right? The closer the area is between these two, okay, you get a cosine similarity. I hope you know this concept. If not, please get yourself familiarized. So based on the cosine similarity, is what it tries to understand whether this is the attention I need and this is the word I have to predict. If it is farther than each other, it'll have a minus cosine similarity. That means it's not related. So that's how. And initially the words are scattered like this without any relation, but as soon as it is trained with more data, it becomes closer, and that's how the probability of king and queen inside a context becomes very similar for a model. Okay. Now this is nothing but an image, right? If you enter an image, this is how it works. So if you see, images are actually calculated like this, and the math works. How the math works behind this is, it takes a particular coordination of images, it adds it, then it creates a convolve. A convolve is different. It creates a vector of its own, and then it saves, and then it pulls the vector, it again puts it into a feature map, and then it predicts the image. So it's a beautiful science in itself. So yeah. Yeah, that's it, right? And if you see this, if I say horizontal image, if I say sharpen, if I say blur, it'll have a similar feature map throughout the canvas, right? Yeah, I think we have covered most of the stuffs. Hope guys, this was very informative video. Please share it with your friends who wants to learn AI. Who you can also share it with your parent to just to understand how AI is. For the first few minutes of this video is covered only with the basics about to show this visualization, how exactly the prompt is given, how the words are broken down into the pieces. You can also teach them, and this is getting embedded. The words are converted into numbers because computer understands the numbers, and the numbers are put into a XYZ map, and then that's how it sees the attention beside each other, and then that's how it gives us the result. I hope this was very informative. I've spent a lot of time creating this tool. This is still in my local host. I'm sure you are able to see. I'm going to release this publicly very soon. There's a lot of work that I have to do on this, but yes, you will get this tool. It's not about sharing the tool with you, it's about learning, right? And I'm sure I helped you guys to understand a lot about AI concepts, and this was very informative. Please share, please subscribe, and comment what else you want me to cover in terms of concepts, in terms of features, in terms of mathematical intuition. If you want me to go to advanced level, let me know. I'll definitely cover that. That's it for now, guys. Thank you so much for staying tuned. Whoever has stayed tuned, I'm sure you would have subscribed. Thank you so much. Have a great day. This is Naresh signing off from Skillwizer. Happy skill tuning.